Welcome back, mathematicians. Today we're going to talk about exponential growth and decay. Um, what we're talking about is super applicable to real life. Lots of things as exponential growth, like bacteria, and when you talk about decay, it's a lot of things like radiation. This is how they figure out how, or when it's safe to enter an area that's been irradiated, stuff like that. But we're going to kind of look at the abstract view and then kind of look at more specific examples later on. So for right now, what I'm going to try to do is graph y is equal to 1/2 x, right? Let's try it out and see what it gives us. So I'm going to let's start with an easy case, right? So the easy case is going to be 0, of course, right? So 0 to the 1/2 power is going to be just 1, right? Just anything to the 0 power is going to be 1, so then that's easy enough. All right, let's try some other examples here. So I want to try, this time I want to try, let's try 1, also kind of uninteresting. 1 to the 1/2 power, well, that's just 1/2. Okay, fair enough. So I put 1, 1/2. Let's try something a little larger. This should be a little bit more interesting. Let's try 3, say. Okay, so that's going to be 1/2 to the 3rd power. If I remember my exponential rules, this is 1 to the 3rd power or 1, and then 2 to the 3rd power, which is going to be 1/8. So if I plug in a 3, I should get a 1/8. What's happening here is you should ask yourself, is 1/2 larger or 1/8 larger? A lot of students will tell me that 1/8 is larger, which is not necessarily, or not true. 1/2 is larger than 1/8. You think of a piece of pizza, right? Half of a pizza is way better than 1/8 of a pizza. So 1/8 is a smaller number. So as our x values get larger, our y values are tending to get smaller. All right, so let's take a look at the opposite direction, see if that's true. I'm going to pick a kind of, let's pick a -4, right? See if that's, so it looks like as I go this way, my graph is getting smaller, closer and closer to 0. Not quite 0, but closer to 0. Let's see if I go with this side of the 0, I should go up. Let's try it. 1/2 to the -4. So if I remember my exponent rules, a negative is first going to move the bases, right? So I'm going to move my bases. I'm going to have that to the 4th power. And then I'll have, this is basically 2 to the 4th power, which is going to give me 16. Okay. So I have, when I plug in -4, I should get a 16. That's a little bit off my charts, but I'll make do. So first point here was in black. 0, 1. My next point is at 1. It's about 1/2. My next point was at 3, and that was at 1/8. Again, it should be getting closer and closer to 0, but not quite there. My last point was at -4, and that was way, yeah, I can't get there. That's about a little less than halfway, so it goes up. So I'm going to graph what I can here, and it's going to look something like, excuse my sketchy, or my shaky hand there. It's going to look something like that. And again, it gets closer and closer to 0 without actually getting there. So if we think about this result, it kind of makes sense, right? If we expand this out, right? So let's see here. We have 1 to the x power over 2 to the x power. Well, anything to the 1 power is just always going to result in a 1. And when we start thinking of larger and larger numbers for this x value, it actually makes this whole number smaller, right? So we start off with 1/2, right? Then we go to 1/4, 1/8. Think about like 1/256, right? This number gets larger and larger and larger, and this overall number gets smaller. So that's what's happening there. So we just keep getting closer and closer to 0, but never getting to 0. All right. So I decided to just bite the bullet and graph it on Desmos here so you can kind of see what's going on. I have a graph here. This is my exponential graph, right, of 1/2. I just decided to write it as decimal, but it doesn't matter, to the x power. And again, you can see how this graph gets closer and closer to 0, but it never quite makes it. And no matter how far we zoom in on this side, it never crosses that 0, right? So you can see here, once I've zoomed in, I'm looking at 1/5 of 1 here, and we're still really close when we get to 7, but we're never going to get there. Okay, so this is going to be called an asymptote. We're going to have an asymptote of 0, and we'll talk more about that later. All right, thanks for listening. I'll catch you on the next video. Welcome back, mathematicians. This time we're going to talk about growth, and this is the second part of our growth and decay series. We have a graph here. It's 3 to the x power. I'm going to do my best to sketch it. Again, I'm going to pick some points out, and we're just going to go through it and try to do our best to graph it. So my first point is going to be 0, right? So I'm going to have, in this case, let's do f of 0. So that's going to give me 3 to the 0 power. That's just going to be 1. Okay, so we should see some patterns here. When you have these guys to the 0 or to an x, we have these bases to an x. When we plug in 0, it should always give us a 1. If it's just a number as our base. Let's pick in some other points here. Let's pick f of 1. 3 to the first power is going to give me 3. So when I plug in 1, I get a 3. And if we try 3 again to the second power is going to give me 9. Okay, so that's fairly interesting. It seems to be going up very rapidly. And we actually have a name for this. This is going to be exponential growth. So let's see, it's 3, 6, and I don't have a spot for 9. This is exponential growth. And what's interesting is how it differs from the other graph. Okay, and it goes to that point, and it goes down, down. Okay, so that's kind of what we're looking at. And again, reading this thing from left to right, so this graph is growing exponentially. So let's take a look at Desmos. Again, this is the graph, kind of a better look at it, right? Done with a computer. So it's going to be a little bit more accurate. Again, we have a growth, right? So this can represent a lot of things. Let me put that other one back in there. So again, in the red, we can see that growth increases in value very rapidly, exponentially, and that our decay graph goes the opposite direction, right? It decays, it gets smaller as it goes down, as the x value increases. What I want you to do now is try it for yourself, right? So I have a function here. It's going to be y or f of x is equal to 1/5 to the x power. First, state whether the graph is either growth or decay. And then, after you've made your prediction, try sketching the graph and see if it comes out how you think it should come out. Okay? And I'll catch you on the next video.